Check, check, 1, 2, check, check, 1, 2. All right, graphing day 2. Now, I kind of gave you a preview in class, but now our main formula is y equals a times the sine of b times the quantity x minus c plus d. Now, each piece of this formula tells us something. Okay, what we learned yesterday was a is my amplitude. A is my amplitude. Okay, and D was my vertical shift. Vertical shift. And that moved us up and down. All right, now today we're going to focus on the next two pieces. We're going to focus on B. And B can really mess our graphs up good. But this B alters or changes our period. So it pretty much changes the scale of our graph, some like to say. All right, and how we find that is we take 2 pi and we divide it by b. Okay, and that gives us our new period. Okay, now C is going to control our lateral shifts. Lateral shifts. So that tells me left to right. Now, keep in mind it's always the opposite of C. Kind of like when we did conics, it was always x minus h. Treat that like our h. All right, it was always the opposite of. So that's what each piece of the formula tells us. So now we're going to examine it and draw some graphs. So let's do it. So we got to use what we learned yesterday and use our new information. So example 1, I have y equals 3 times the sine of 2x. All right, 3 times the sine of 2x. So we have to identify my period. All right, we have to identify my interval, my amplitude, and then we have our lateral shift and horizontal shift. I'm sorry, vertical shift. And remember, those are after our dotted lines. So we like to take care of that afterwards. All right, now I'm going to scroll back up just so we can kind of focus on the equation here. So first I want to talk about my period. Now, my b value is now 2. Yesterday we always had a period of 1. So that's why it was always 2 pi, because 2 pi over 1 is just 1. So here my b value is 2. So my period is going to be 2 pi over 2. All right. So we got that by taking 2 pi over b, which was 2 pi over 2. So my period is just pi. Okay, now your interval... Okay, your interval is always your period divided by 4. Again, because on our unit circle we have 4 tick marks, so that's a full period, so we're going to chop it into an interval of 4s. All right, so this is pi over 4. My amplitude is my a value, which is 3. All right, so with that information, now we graph. So I have my 2 axes. Make that a little longer. Okay, now, my period is pi, and my interval is pi over 4. So my period is going to go from 0, and my last dot's going to be pi now. All right, so it's a little different. Yesterday we were always 2 pi. Now, my interval is pi over 4. So that's going to be my first one. Now, my next two, we're going to climb by 1/4. Right, so think of a full pi as 4 pi over 4. So is it 1 pi over 4, 2 pi over 4, 3 pi over 4. So reduce this, we get pi over 2 and 3 pi over 4. All right, and then my negative is the same thing. All right, so now again, our period and interval change. So now we're it's creating a new scale for my graph. All right, now I'm going to erase these down here to get out of our way now that we understand where it came from. Now my amplitude is 3. So I'm going to go up 3 and down 3. Now, we're still focused on the unit circle. All right, our idea hasn't changed. Okay, we still have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right, so we're dealing with sine. Now, sine always starts at 0. Sine always starts at 0, and it's positive. So we follow it around like we always do. So my first goes up to 1, back down to 0, back down to 3, back to 0. Okay, and then the opposite way. Go to -1, 0, 1, 0. Now, our lateral shift is none, and our vertical shift is none. So we don't have any shifts there. Now, I want to talk about this for a second, though. Notice how we only went to pi. Now, yesterday, you don't have to draw this, just listen. We went all the way to 2 pi. All right, so yesterday, okay, our graph would have looked kind of like this. All right, it would have crossed at pi and ended up back at 0, 2 pi. That was one full period. So now our period was cut in half. So what happens now is this graph moved faster. All right, so this graph did a full period, okay, a full shift in half of a period, kind of. All right, so yesterday we kind of talked about moving our graph up and down when we stretched our amplitude. And today, now what we did is we kind of squeezed it side to side, and this graph moved a lot faster. So that's what that 2 did. It kind of told your graph to move twice as fast. So we were able to fit a full period in half of it. All right, so we're only graphing one full period of the graph, and that's why we adjust it as follows. But that's kind of why we did the graph that way, and that's kind of why it reacted that way. So hopefully I'm not talking too much. We're running out of time, but let's do another one. So hope that makes sense. We'll touch on it tomorrow. All right, let's look at another one. Let's look at this one. Y equals the cosine of x over 3. All right. So now we have our period, my interval. All right, remember your period is 2 pi over b. So in this case, it's 2 pi over 1/3, because 1 over 3 is my b value. So 2 divided by 1/3 gives me 6 pi. So now my interval is 6 pi over 4, right? It's always the period over 4, which gives me 3 pi over 2 as my interval. My amplitude is just 1, and my lateral shift and vertical shift, I keep putting horizontal, vertical shift is none. All right, again, I have no number back here and no number in front. Okay. So there's no number in here, and there's no number in back. So no shifts. Now, again, I did this on purpose because I really want us to get this period and interval thing down pat, because it's kind of changing the way we think about these graphs. All right, so my period is 6 pi. So I'm going from 0 to 6 pi. And my interval is 3 pi over 2. 3 pi over 2. All right, now we got to think about this one a little different, because 6 pi is really 12 pi over 2. Okay, and we got to chop this up. So 3 pi over 2. So from 3 to 12, there's 9 spots. Right, so 3, think about it as like a number line. Right, you have 3 here and 12 here. We have 4, 5, 6, 7, 8, 9. So these are kind of my spots here. So this gives me 6 pi over 2, and 9 pi over 2 is how I chop up that interval. Okay, 3, 6, 9, 12. Right, chopped up into 4 equal pieces, and just tack on pi over 2. So this simplifies to 3 pi, and this one's 9 pi over 2. I know that was a little tricky, but I hope it made sense. Just chopping it up into 4s. So then over here, I mirror that. All right, so that's the hard part. Now we're talking about cosine. My amplitude is 1. So cosine always starts at 1 or -1, depending on what my graph is. Here my graph is positive, so we're starting at +1. Cosine, next one is 0, -1, 0, back home. Okay. Here, I need my other tick marks. I'm back to 0, -1, 0, back home. And here's your graph. So the tricky part there was breaking down this interval because we haven't seen anything like that. But again, it's just splitting the difference evenly amongst these two. All right, let's keep plugging along. Okay, so now that we've done two examples looking at our intervals, let's incorporate these shifts. So example 3, y equals the sine of x minus pi over 2. X minus pi over 2. So my period, well, it's 2 pi over b. In this case, my b value is just 1. So my period's 2 pi. Now my interval, your interval is your period over 4, which is pi over 2, or 1/2 pi. Here my amplitude is 1. Now, my vertical shift doesn't exist. There's nothing there. However, now I have, okay, now our lateral shift, all right, we said is pi over 2. So because we have a lateral shift, we're going to draw a dotted line first. All right, so let's go ahead and graph. Our period is 2 pi. So again, that's what we're very accustomed to. It's kind of our standard position, our standard radian measure. All right, we're in both directions. Negative 2 pi, negative pi. Put your other ones. All right, we're a sine graph, so we always start at 0. Oh, my amplitude is 1 and 1. Okay, we're a sine graph, so we always start at 0. All right, and then we go up to 1, back to 0, negative, back home, and then we go down, 0, positive, back home. All right, so there's my dotted line. All right, now, my lateral shift is pi over 2, so we're moving to the right, all right, because it's positive. Remember, it's always the opposite of, so we're moving right pi over 2. Now, our interval is pi over 2. So we're moving everything right 1 unit, and that matches up with our interval, so that makes it nice. So just take each point, and we're going to move it right 1. So I'm going to start here, go right 1. Here, right 1. Here, right 1, right 1, right 1, bam, bam, bam. Now, we're missing this last one, but where would this graph come from? Think about it. It would continue down here, right? So my next interval would be right here. So just follow the pattern to figure out that. Whoop, I missed that last point there. So there's my last graph. Now, just like yesterday, except for now we're shifting left and right versus up and down. All right, now, one more example. I'm going to start you off, and then you're going to finish it on your own. All right, so this is example 4. And I have y equals negative 2 times the cosine of 1/2 times x plus 2 pi. So now my period is 2 pi divided by 1/2, which gives me 4 pi. My interval now, right, is 4 pi, my period, divided by 4, which is just 1 pi. I have an amplitude of 2. My vertical shift, there is none, because there's nothing in back here. And my my lateral shift is the opposite of 2 pi, so negative 2 pi. So that tells me my graph is moving to the left 2 pi. Now, that's the tricky part. Okay, so I want you to graph and see if you can apply this. See if you catch how 2 pi is different with our interval being 1 pi. All right, so try to connect those two things. How our lateral shift is 2 pi, my interval is 1 pi. So when my graph's moving, you got to be very careful. It's kind of sneaky. All right, and also you're graphing a negative graph. So try your best, come up with a graph, and we'll go over it first thing tomorrow. All right, see you then.